So for the last half of this review, we just have to solve this. Notice there's an equation. I'm not doing the proof questions because we've already done the proof questions in previous homeworks, so I will not be going over those. But here, if we get everything equal to 0 and solve, get everything equal to 0 and factor is often what we need to think if we are trying to solve an equation by hand. Okay, so factoring that sucker, I view it as having two terms, this minus this. What's common to both terms is sine theta. Sine times what gives you this? It'd be tangent. And then I guess you ask yourself, sine times what gives me negative sine? So it's -1. Boop. So if that's equal to 0, then if I have two things that multiply together to get 0, either the first one is 0 or the second one is 0. So either tangent of theta is equal to 1 or sine of theta is equal to 0. So for here, if sine is y, then I want to know where's my y coordinate equal to 0. So if y is equal to 0 at the end of a long day, if y is equal to 0, that's going to happen here at theta equals 0, or over here at theta equals pi, right? And then over here for tangent of theta equals 1, we know that that's going to be over here at pi over 4, because you've got the square root of 2 over 2 and the square root of 2 over 2 for the cosine and sine. So sine for the cosine and sine, the x, y. So sine over cosine is going to be 1. Down here at 5 pi over 4, you've also got a cosine and a sine that when you take the sine and divide it by the cosine, you also get a +1. So it turns out that you could have theta equal to, well, I could put both of those answers plus 2 pi, or since they're across from each other, I'm just going to have my first answer as 0 plus 2 pi. I'm sorry, 0 plus pi n. That's going to give me both of those. Over here, I'm going to put my theta 2 is equal to pi over 4 plus pi n, and that's going to get me both of these because they're pi apart. Remember, if you want to have each one of these plus 2 pi n, that would have also been okay, but I'm going to write it as this one and this one here, and that one there. All right, last one, then we're done. Solve this equation and express the solutions in both radians and degrees. Just pick one, who cares? So here, if I've got 2 sine squared t minus cosine t minus 1 equals 0. I want to get everything equal to 0 and try and factor maybe. I wish I could factor, but I can't because I have different functions floating around. So if I can rewrite sine squared as 1 minus cosine squared, I think I will be much happier. So now when you distribute, you get 2 minus 2 cosine squared. Then if I get everything over to the right-hand side, well, do we see that this and this are going to give you a +1? So we really have this minus cosine, what, +1? So then when I move everything over this way, end up getting 2 cosine squared plus cosine minus 1 is equal to 0. So I want to take that trinomial and break it into 2 binomials where the first 2 multiply together to get the first, and the last 2 multiply together to get the last. So I think it's 2 cosine and a cosine. Then I need a 1 and a 1, but to get the correct middle term, that's going to be positive and that's going to be negative. So 2 cosine t minus 1 must have been 0, or cosine of t plus 1 must have been 0. So I think you'll see that you get cosine is a half, or cosine is -1. But I know that cosine is just the x coordinate on the unit circle. So for the x coordinate, on the unit circle, if it's 1/2, then that's going to be here or here. So if I look in the first quadrant and I want cosine to be 1/2, it must have been pi over 3, right? That's where you're going to get 1/2. And then if I have the same reference angle down here, instead of 3 pi over 3, this one's going to be 6 pi over 3. So if I back up 1, this is 5 pi over 3. So I think I'm going to have my 5 pi over 3, my 3 pi over 3. Over here, where is cosine or x equal to -1? So this is x equal to 1/2. This is x equal to -1. It's just going to be a pi. So it seems like all my answers are t is pi over 3, t is 5 pi over 3, or t is pi, but guess what? It could be plus any number of wasted revolutions. And I think that's it. Great work. Best of luck on the test. Remember to look back through all of your old homeworks and also on the proof questions. Definitely look back at the old homeworks or anything that we did in class. Best of luck.